So all of our talk about work has really just been to get us ready to talk about energy. And there are two main types of energy, kinetic energy and potential energy. In this video, we're just going to focus on kinetic. So kinetic just means the energy of motion. Kinetic means motion, so kinetic energy is the energy of motion. And we can ask ourselves, what has more energy? A big old dump truck going 10 meters per second or a shopping cart going 10 meters per second? All right, so most people probably said that the dump truck would have more energy, and we'll talk about why that's true in just a minute. But what about this situation? We have a shopping cart going 10 meters per second, or we have another shopping cart going 20 meters per second. So which one of those do you think would have more energy? The shopping cart going 10 or the shopping cart going 20? So most people probably said the 20 meter per second shopping cart, and they would be right. But let's talk about how we can figure that out with math. So what does kinetic energy really depend on? I want you to think back to what you thought were the answers, what we figured out were the answers for the last two questions that I asked you, and what was it that made the dump truck have more energy, or the second cart that was over on the right-hand side have more energy? Hopefully you came up with mass and velocity, or some combination like that. And so when we look at our equation for kinetic energy, it's going to have an m for mass and a v for velocity. But it's not just that. That would give us just momentum. When we're talking about kinetic energy, we actually have a couple other things in here. We have this 1/2, and we have a squared. So remember, squared means times 2. So basically I have 1/2 times the mass times the velocity times the velocity. So the velocity is in there twice. And that is our equation for kinetic energy. And if you're curious about how we come up with these numbers, come talk to me after you've had a calculus class. Okay, so let's do an example. How much kinetic energy does a 0.15 kilogram baseball have if it is moving at 30 meters per second? So this is kind of a throwback to a question we talked about when we were doing momentum, but now we can talk about it with energy. So as always, I want to highlight what is the information that the question actually gives us. We have 0.15 kilograms and we have 30 meters per second. So we need to figure out what are each of these numbers. What are they talking about? All right, so you probably were able to figure out that since we have kilograms here, we must be talking about mass. And since I have meters per second here, I must be talking about velocity. And if I recall my equation for kinetic energy from the last slide, it is that KE, so kinetic energy, equals 1/2 times the mass times velocity squared. And now what I can do to answer my question of how much kinetic energy is I can just plug these numbers into my equation. So when I write that again, I'll just substitute in what I know. KE equals, 1/2, that's staying as 1/2. And then my M I know is 0.15. That was kilograms. And then my velocity was 30 meters per second. And that whole thing is squared. So that means I'll multiply the 30 twice, or I'll square the 30 and multiply it by the rest. So punch that in your calculator and see what you end up with. All right, so when you get your answer, that should be 67.5, and we're going to combine our units, kilograms times meters, but remember meters got squared. So kilograms, meters, and I forgot my G. Kilograms, meters squared, and then my seconds are on the bottom, but they also got squared. So I have kilograms, meters squared per second squared, and that's a lot to write. So we come up with a little shortcut for that, and that is 67.5. We're just going to call that, let's call that sloppy. Okay, we're just going to call that unit J for joule. That's Joule. And that is our unit for energy.